talk a little bit about draft. We're going to take a look at this part from the front. And what I'm going to do is up here on the top, the side that we said, what you probably shouldn't do. Basically, I'm going to draw a line, and the right edge of this box is a completely vertical line. And you can see that that top half is completely straight, has no draft. And what happens is when you go to pull that part out of the cavity, this entire surface drags on the steel the entire way out. And if you've ever tried to take two 5-gallon buckets apart and they've kind of vacuum locked on you, you know that that's a pretty impossible situation. It takes a lot of force to get some air in there to break that and to finally get those buckets apart. Same thing happens with your injection molded parts. If you don't put draft on them, it becomes really a higher level of force required to push the parts out. And when you're using injector pins and you're pushing really hard, oftentimes you can misform or warp the parts as they're still a little bit warm. They're not 100% cooled. And if draft is added, it makes it much easier to push the part out of the cavity. And so what I'm going to do is the same exact thing. I'm going to say that the right edge of that blue box that I'm drawing, and you can see in the part that it's drafted down, the minute those ejector pins push this just a little bit, it breaks that surface, and the part is much, much easier to get out, requiring much less force. And that reduction in force basically gives you a more repeatable and more desirable part. And what I want to do also, so now what I just showed you was the draft on the cavity. What I want to show you now, that the inside of this part has draft as well. I'm going to draw a box that goes up inside the tool. And now what we're looking at is the left edge of this green box compared to the geometry of the part on the inside. And you can see that there's draft on that component as well. And so successfully demonstrating, what a typical draft would look like on a part, and a part that will eject much easier and have less warp and better repeatability and better part appearance as a whole. So basically, you should basically apply draft to the cavity of the tool, and you should also apply draft to the core of the tool.